All right, welcome to our webinar. This webinar is provided by eTool. Today we will talk about the LCA and how it can be used for the new Green Star Buildings rating tool. Everyone is now in a listening mode. You're muted. Just in case you have any questions, feel free to write them in a chat field. And then we can go through your questions during the question and answer session. To start, I would like to acknowledge the traditional owners of the land on which we are meeting and pay my respects to their elders past and present. My name is Maria. I'm Business Development Manager at eTool. I would like to provide a quick introduction about eTool to start with, and then we can explain how to use the power of LCA for certain credits of the new Green Star rating. Henrique, who is our lifecycle designer, he will demonstrate in the software how it all works. And after the software demonstration, we will have about 20 minutes time to discuss your questions. So please feel free to write your ideas, thoughts, share your comments with us. And then this way we also will have a more interactive session. So for those who haven't heard of eTool, quick introduction. eTool serves the organizations who are aiming to lead the industry in delivering low carbon buildings and infrastructure. We are recognized for our integrity, teamwork, and passion for the environment. And we provide certain services and products to the clients. So we provide a license to our in-house developed software, eToolLCD and Rapid LCA. eTool software is targeted for large construction projects, both building and infrastructure, as well as to manage carbon of assets. And Rapid LCA is an app that has been very recent and designed for small residential homes. For products, both these products are aligned with the best practice and international standards for life cycle assessment. We also provide training and certification service to our users, and some rating schemes such as Green Star and A-Skies, require all the LCAs to be third-party reviewed. And finally, we'll provide modeling and consulting services, and can be also engaged if you need help. You need help with value engineering. We can also include both environmental and cost modeling and assessment. So I'd like to start now and talk about the Green Star Buildings. As you know, it was launched in 2020, and there is a small transition period during which projects were built to register either for the existing Green Star design and as built, or for Green Star Buildings a new rating. So the transition period is going to expire on 17th of December 2021. And it's really exciting to see the transition in Australia towards more sustainable buildings, and also to see really quite challenging targets. Also, as you're aware, there is lots of talks about embodied carbon, and MECLA is doing their bit, trying to arrange with the industry and coordinate the actions to achieve more sustainable outcome. So what it means for LCA users, and so this webinar is really to inform you and to discuss what this changes means for the LCA. We had a look at Green Star Buildings rating tool and specifically positive category, and identified certain credits where LCA is applicable. So we calculated that about 12 points could be achieved, and here are the credits that can be used for life cycle assessments, and you could get the results out of the modeling. So credit 21 is upfront carbon emissions, 24 other carbon emissions, 26 is life cycle impacts. It's the classical life cycle assessment model, as you know in the past, known as materials credit. There is also a climate positive pathway that you may have heard of. The way it works, so you need to combine 4 credits into one package. So 21 credit and 24 credit, as well as 2 other credits from a different category that LCA doesn't cover based on the guidelines. So energy use and energy source. And then you get additional leadership challenge points. So unfortunately, energy use and energy sources, although it's part of the life cycle assessment, cannot be targeted for these credits. And but you can extract the information and also optimize your design regardless. Also to give you more information about it, I inserted here the link. You probably know of our support website, support.eToolLCD.com. So if you go on this website and then type in Green Star Buildings, you will then get a support article that we created for you. So while it's loading, so I'm just going to do it for you. And it comes as a first article. There's a lot of information in here where we put together for you to go in detail when you need it, and basically covers these 3 credits, but I will go through this in detail now during the presentation. So let's start with upfront carbon emissions, credit 21. So to achieve this credit, you are required to reduce upfront carbon by 20%. This will give you 3 points, and the modules that are included here are A1 to A5. As you know, per international standard 15978, so we're speaking here about this field upfront carbon, modules A1 to A5. So this is basically carbon that is being locked into the building before it starts operating. Transport emissions and construction emissions are in here as well. And then module B and 6, so B module operational, maintenance, replacements, energy and water use. This is not part of this, and C module is end of life. So interestingly, also to achieve this credit, you need to offset demolition works of existing building if it's a relatively new building. So instead of you modeling this building that will be demolished, you can also simply use whole of life building templates to estimate module C. And Hikyo will show you later in the software how you do this. This will ease your life a lot, and you can do it relatively easy and fast. So then you can purchase offset certificates for this carbon from demolition of existing building. If you wish that your project goes a step further and is able to reduce embodied upfront carbon more, then you can explore exceptional performance, which would give you additional 3 points if you are able to achieve 40% reduction in A1 to A5. Important note is also that this additional 3 points are only available if you're using LCA pathway. So you will need to conduct an LCA and then extract the information for upfront carbon for A1 to A5 to unlock these credits. All right, so next one is credit 24. As the name says, it is about other carbon emissions, so those that we haven't covered. It could be from refrigerants, upfront carbon that is remaining. The remaining carbon sources should be all eliminated or offset. So to achieve 2 points, you need to look at your refrigerants and try to eliminate them and offset. And again, Enrique will show you how to do this, because usually this information is included into the LCA model, so you just need to know how to extract it. And then additional points can be achieved for exceptional performance if you look also at other categories. As I said before, here in the description of this credit, you can look at, for example, emissions from buildings, energy use, if it's a not net zero building. You can also look at upfront carbon emissions, so you try to minimize them and then you can offset them to achieve extra points. If you're not using LCA pathway, you can also look at module A5, because in upfront carbon calculator it's not included. But if you use LCA pathway, it's already there, so you can ignore this point. You can also look at modules B and C from the LCA model. Try to optimize them through the lifecycle design, and try to reduce this figure so that you don't need to purchase too many certificates for this part. You can also look at construction waste emissions and any other significant emissions that are above 1% of the total. Right, so I'll just go back to the last credit I'd like to talk about is credit 26. So this is basically means you need to conduct a whole of project, whole of life cycle assessment using 60 years lifespan. So similar as before, using methodology provided by EN 15978 and reporting to include modules A, B, and C and D. On top of that, you also need to use decarbonization grid scenario because the grid will be decarbonizing by 2050, and there are some rulings there that Enrique will cover as well. And the results will need to be reported in square meters of cross-flow area. You need to demonstrate 30% reduction in life cycle impact. So it's not only about carbon, but also about other impacts such as acidification, eutrophication, and so on. So really similar, like in previous situation of design and as built rating. And then the results will need to be entered into the GBCA LCA calculator that is online. And this calculator will then apply normalization and weighting factors to the results. So this much is from me. I'd like now to pass it to Enrique, who will show in the software how it all works.
Thank you, Maria. It's very good. Let me just bring up my screen. Do you have to make myself the presenter now?
Yeah, I just did it now.
So I'll just change to the second screen. Can you please confirm you see the screen? Just a little story. This is really interesting as we get familiarized with the new rating. We are doing test case projects, getting the software ready to automate the reports, make the life easy for the users as we learn more about the new rating. And as I was preparing for this, I found this article that I wrote back in 2019 when I went to the Green Build conference in Atlanta in the US. And there was a lot of talk about embodied carbon, which was really exciting at the time. You all know we are very, we've been on the front line of these for a long time at eTool. we always highlighted the importance of embodied carbon and whole of life carbon. And since 2019, when I went to this conference, I was like, okay, now this is happening. You know, everyone is paying more attention to this, and we're going to drive change rapidly. And it's really good to see the changes now implemented in a new rating for the Green Star buildings, because it does highlight the importance of the upfront and the embodied carbon. Also to do with the timing, you know, it's a lot of emissions that occur upfront at the project lifespan. So this is a projection from Architecture 2030 saying that the new construction up until 2050, 50% will be embodied carbon, 49% actually. And this one is more interesting because until 2030, 74% will be embodied carbon. So all the initial emissions that we send to the atmosphere at project completion, and then the operational energy kind of builds up with time. And as we improve energy efficiency, decarbonize the grid, then all the upfront or the embodied carbon becomes more significant. So really good to see this, the new rating and what's coming for Green Star buildings, because it is it's more strict targets for materials and embodied carbon in general, but it is necessary. So it is going to drive significant change in the industry, which is really exciting. And eTool, we're here to help, you know, as a solution provider, as software provider, as specialized consultancy to help that transition occur. So I'm going to jump between the slides here. It's actually a very basic presentation. I'm actually going to use more the software to present an example project that we're using to test and demonstrate how to meet the credit compliant requirements. For those that are familiarized with the software, it's going to be a little bit easier because I'm going to use the software a lot. For those that are not very familiarized, I apologize, but I think you get used to the interface and how the software works, so it'll make it easier in the future as well when you actually have a project to work on. So we're going to be using at the project level here the lifecycle modules to segment the scope and navigate through the results. I'm using a typical office building in Australia to represent what a reference result, you know, for business as usual, what it looks like. And we can see that following the Green Star requirements for energy, code compliant, building fabric and energy efficiency requirements, it's usually dominated by energy. Also because we are looking at the 60-year lifespan. So this is a very common profile for a reference building. And the final design, when all the improvements are implemented, most of them coming from energy efficiency, you see the big change that coming from energy. So from 7.5 tons per meter square over a 60-year lifespan down to 4.6 tons. And you see the majority of the savings is coming from energy improvements. So I think what the new rating is going to drive is a bigger change in this materials section here, and highlighting the importance of that in the timing, you know, the urgency we have in minimize the emissions today. So the first example here, what I've done is I looked at the impacts for A1 to A5 only. This is the first line. So this is only the upfront carbon. And then I compare the reference design with the final design. A 28% reduction initially. And the reason why I have two options is because now with the Green Star buildings, you're segmenting the emissions considering upfront carbon only. And with that limited scope, you cannot account for the carbon sequestration offset. So a timber product will have a neutral impact, but it cannot have a credit. So it would therefore offset impacts from another product or different life cycle. That's not permitted in the rating. So what I've done is I looked at the improvements made to this project. This project was a typical reinforced concrete building. There's a reference case, and the proposed final design uses mass timber. Some of the structural elements, floors, slabs, columns, framing, partial elements were replaced with mass timber. But these originally these products have a carbon sequestration credit, meaning that you would provide the savings, right? But these savings here, 102 kilograms of carbon per meter square, cannot be accounted. So you need to add them back up to the total impacts in the final design, which reduces the savings to from 28% down to almost 16%. So I'll just show you this in the software as we go through these examples. First of all, we will segment the scope by turning these other lifecycle modules off and saving the design. So we can very rapidly narrow the scope and focus on this upfront emissions. And I'll refresh this one. So now we're down to 800 from that 7.5 tons. Now we're down to 0.8 ton or 800 ton or 800 kilograms per meter square. I'll just refresh the final design here as well. So you see if I use one of these templates. So this is the original model, how it's represented in the software. If I use one of the CLT templates, for example, this one here, you see that at a product level, from module A1 to A3, it gives me the carbon sequestration credit here. So this is what is not allowed anymore in Green Star buildings. What it says that you can consider this as a neutral product, so it needs to be zero. It will still provide savings, right, compared to a concrete element, a reinforced concrete element, but it cannot provide a credit. So what I've done is I went through the elements that had carbon sequestration credits and removed them from the model. So to actually represent what the credit requires. So this is one of the new requirements. The other one is regarding upfront carbon is that you have two pathways. You can use the Green Star calculator, and that is a limited scope. It's only the product stage from A1 to A3, or you can use the life cycle assessment pathway, and that includes also transport and construction, which is A4 and A5. So you see from this the total final design impacts this is on a per meter square basis. Almost over 27% of the total impacts are coming from transport and construction. So I think there's an advantage here. First, because you're extending the scope. At eTool, we've always promoted for you to capture as much as possible within the building, the system boundary. because that will give you more chances to reduce impact. The more you capture, the more you calculate, the more you quantify, more chances you have to identify these hotspot areas and reduce impact. So if you need to demonstrate reduction regarding concrete transport optimization, which is usually one of the biggest transport impacts, or if you have any plant efficiency for machinery and equipment use and you need to demonstrate reduction, the LCA pathway is the only way you can use to demonstrate savings beyond materials in your upfront carbon. So you can also demonstrate savings in your transport and construction. The other interesting thing about the LCA pathway is that you can integrate with specific product declarations. So you can use EPDs to demonstrate savings from materials. And the nice thing about this is that it creates consistency, because the default life cycle inventory and EPDs, they all follow the same standard, EN 15804. So you create that consistency when replacing inventory data with specific product data, and that's really important for the industry in general to have that consistency. Okay, and you also, if you are developing a new site with an existing building, there are certain rules regarding the age of that pre-existing building, but you have to offset the demolition impacts. And I have saved here templates. We have pre-configured templates to help users quantify those impacts. Sometimes you have to do a little bit of modeling to understand the original, the existing building elements, the materials. So it's a combination of these which are capturing equipment use. So demolition templates that will account for machinery and equipment use. But you can also use benchmark buildings or typical buildings that you already have in your account to calculate associated emissions with demolition. So the waste processing, transportation of those materials to landfill or recovery facilities, and also a disposal impact. I'll just again segment the scope here so you can see one example of how you can calculate demolition impacts this is from existing buildings, right? It's important to defer the scope, because the demolition of the existing building, it's not part of the actual LCA that you're conducting, because this is part of the existing building system boundary, right? Only Green Star it takes into account, so it's offset, but we're talking here about demolition of existing buildings, which is not part of the actual scope of the LCA. So you can use all the designs to calculate this, just to get a reference figure, because you do need to calculate this in order to offset. So I use the same example, but don't get confused, right? Just to show you how you can segment and have a reference figure. So we'll just turn the end of life stages on here, and we'll go back to my reference model and navigate to the analysis tab. So this is an example. If we had that building, similar type of building, demolished, this would be the biggest impacts, and this would be the amount of carbon you would need to offset. So 1,395 tons. So this would comply with that demolition offset requirement, which I have highlighted here. So moving on, because we do have a lot to go through. The other one is regarding refrigerant gases. Refrigerant gases is identified, as we know, as a big emitter. The biggest emitter from services, not only the initial charge, but also the leakage, the losses during operation, as well as the end of life, depending on the recovery rate of those gases. There's a lot of impact going to the atmosphere. So it's good that Green Star is targeting at least the offset of the initial charge. And I'm using one example here. I think you have two options as well. I haven't seen yet the Green Star table. This is a very simple table with the different gases and the emission factor for each one on a kilogram basis. So you can do a simple calculation depending on the amount of gas you have on your system. So I'm using the data from the software here to estimate the amount of refrigerant gas from a chiller. I have the coefficient of impact for our 410A, the amount of gas, so the mass of the gas, and the associated carbon, so 807 tons of carbon to be offset or eliminated if I use a different gas, a natural gas, or a gas with, I think, GWP below 100. It also meet the credit compliant. So it's very simple, but very important, very powerful, I think, to offset these gases. A little bit beyond the Green Star credit and highlighting the life cycle design approach is it allow designers to compare the HVAC options considering both energy efficiency as well as the embodied impact. So if you're testing different systems, could be small split systems or chillers, large commercial systems, take into account not only the energy efficiency and the coefficients of performance, but also the embodied impact with the gas. So you can compare different systems with a more holistic approach. So, and also look at the simulate losses and end-of-life recovery rates and have a long-term view on these HVAC systems. As part of the same credit, the other carbon credit, you also have the exceptional performance that Maria touched on earlier. And that's very, you need to offset the remaining emissions, right? So we're assuming in this example that the project is net zero operational. So that is already been accounted for, and that depends on the results from the energy source and energy use credits. Then you have to offset your upfront carbon emissions, and this is what we calculated for on a meter square basis multiplied by the area of this example project. It's another nearly 19,000 tons to be offset just for the upfront carbon emissions. And you also have to offset the other operational and end-of-life emissions from Module B and Module C. So that equals to 9,625 tons associated with the other life cycle stages as part of Module B and C. So I'll just quickly show you also how you do these to grab this information out of the software. I'm navigating on my final design. So I'm just going to bring up the final design here. So what I want to do, I've already accounted for the upfront emissions. So what I'm going to do now, I'm just going to turn the operational modules on, considering energy operational energy is net zero. So I'm not going to take into account. So I'm just going to calculate the final emissions here. And then you go into your analysis. This is really useful for those that are not familiarized with this feature. It's not very recent, but quite, I think it's probably a year old now. So you can have a look at the results without generating the reports. You can do different graphs and bar charts. And here's the total 9,624,000 kilograms or tons associated with B and C life cycle stages. But it's really interesting. I think you can extract a lot of information out of this as well. If you're doing this at concept stage, you look at the replacement as the top impact, and then you can look at, for example, the top impact report to understand where these impacts are coming from, these replacements, or the majority of the impacts, the hotspot areas. You can play with the automated reports to understand recurring impacts, which was highlighted as one of the top areas that we need to offset. And then we see things like carpet that initially doesn't have much impact, but throughout time with the replacements that accumulates, and also refrigerant gases that's already been offset on the other credit, and so on. So aluminium as well, and plasterboard, and so on. So it's a bit more detail on not only accounting for the amount of carbon that need to be offset, but first and foremost, understanding where the impacts are coming from and reduce them, eliminating them before you have to offset. Okay, so this is the other carbon in order to achieve exceptional performance. Then we go into the last credit, which is life cycle impacts. And this is closer to what we usually do at eTool as a standard life cycle design services scope, which is to capture the whole life carbon emissions from module A to module D. It's important that the input, the LCA data input, is consistent with the other Green Star credits. So your energy use, your annual demand for the different categories, your water use, and your EPD, or your just getting a sign here for slow connection. If you have any problems, Maria, let me know. I'll just ignore the warning here.
That's all right.
So you also need to align your study with EPDs, and as part of the responsible product credit, make sure the whole life cycle model is aligned with those other credits as well. In this case, you can account for the carbon sequestration because the end of life impact is included, and I'll show you what this means. I'll actually show you now. On a whole life scope, the full life cycle scope from module A to module D, if we bring up that same component that I showed earlier, let's say a CLT floor, so there's a lot of different templates for this project. Just try to grab one of these. So this one, for example, I don't know if you remember, but when I have the upfront carbon only, it will only take into account the benefit or the sequestered carbon. But now with the full life cycle, it also takes into account the end of life impact. So it's the carbon returning to the atmosphere at the end of life, the timber end of life. So because we're now looking at the full scope, you can account for the carbon sequestered, for the sequestered carbon. And you see that, for example, for this CLT floor slab, although you have some credits to begin with at product stage, you have to account for the transportation impact, the construction impact, and also the end-of-life impact. So you end up with a small impact overall, but that provides a saving compared to a reinforced concrete slab, for example. So this is the full life cycle scope. And the other aspect with this credit is that you have to consider the grid decarbonization scenario. And the reason why this is important is because we know how important it is, and the government targets, the global targets to decarbonize the grid. And the current standard, LCA standard for buildings, the calculation method, requires you to use the current emission factor throughout the whole lifespan. That is to reduce uncertainty. So, but it means that we're going to continue with the same carbon intensity over the next 60 years, right? Which is not accurate. So the benefit of considering the grid decarbonization scenario is that it's going to diminish the benefit of those energy savings, because the energy impact is not going to be so significant anymore, right? So it's bringing the responsibility, it's way more towards the materials and the embodied impact with this scenario. The software is ready to simulate future grids. We actually have a 2050 grid, which is 1/4 of the current Australian grid. Or at least in this example here, the regional grid, the current regional grid is 4 times more carbon intense than this 2050 grid that I used. So you can see that the first scenario is the whole life carbon using the default grid. The impacts are quite high, 7.5 tons per meter square. And the final is 4.6 tons. When we consider the decarbonization throughout time, the impact reduced significantly to 3 tons and 2.2 tons. So does the percentage reduction, right? Because you are now improving on an area of your project that is not so relevant anymore as it is when you use the current grid factor. So again, this is putting more pressure into the initial upfront emissions. The way you do this in the software is very simple, because you already have your reference design. Let's say you want to use these, you want to create a model like this. This one is already the grid decarb scenario. You can quickly use the bulk swap. And this is the nice thing about software, is that it just speeds up the process. Not only the import of the data that you can integrate with Revit or use a CSV import, but you have these design features to help you identify hotspots, make bulk changes, and avoid spending time entering data or changing things manually. It's all using the smarts and the software to make your life easier. So you go into the energy, you find the electricity components, for example. You select all the HVAC components. I'm going to move them all. You're not changing the grass because we only decarbonize electricity grids. So you have to skip this one, and then you change all the other ones to, you select the parameter, you're changing the source. So you're changing the electricity grid to the 2050 business. So this is creating that decarbonized scenario, and you can see the savings just by moving the grid. There's already the 74,000 tons of carbon saved. So this is how you create that grid decarb scenario and arrive at a model like this. So you get your grid decarb for the reference and also your grid decarb for your final, and you can extract the information here to report your life cycle impacts. You also have the normalization and weighting, and this is part of the, I'm just trying to find this quickly here. Oops, need to refresh this page. The normalization and weighting is set by Green Star to give emphasis on regional priorities. So you have these life cycle impact indicators, or sorry, environmental impact indicators, and then you have normalization factor and weighting applied to each one of them, and that will create a unique final consolidated result, and that is the result that you plug into your Green Star life cycle impact calculator, and it calculates the weighted and normalized results, the percentage improvement, and then it calculates the number of points. So if you achieve the 30% savings, you get the 2 points for the life cycle impact credit. So what we, as I said, we are looking at improvements that the software needs to facilitate the modeling and the reporting of these credits. And one of them is to create an automated report out of the model. So when you're running a report, instead of having to extract all the results manually and input one by one, because it's a lot of data here to input manually. I know GBCA is coming with this feature soon to import the data, which will make it a lot easier. But the goal with the software is to produce the same result, the normalized and weighted results with an automated report, which is what we do for different ratings. So when you characterizing the impact, you would have an option here to use a normalized and weighted impact, similar to what we do currently for ISCA. ISCA has a normalized and weighted enviro point, which consolidates all the different impact indicators into one parameter. Right? So we'll have that. We'll distribute that to our users as a new feature request. So make sure you vote for it and help us prioritize it. But that is the goal, to make all these reports, the template reports, available in the software. So without much further explanations, I'll just wrap it up here and give everyone a little bit of time to answer or ask questions.